data is what I'm gotten. So next is going to be your output. Discrete values. Discrete values is nothing but, for example, spam messages. If it is a spam or not, how will I identify it? If it is a cat or dog, how will I define it? If the disease is present or not, how will I identify it? So what? So this is how I'm going to say that if these are the parameters are available, I can predict this is a cat. If these parameters, if these are the specification, if I have it, I can identify this is a dog. Like that, I can say that this disease is present or not. Is a spam message or not a spam message. Like that, I can, if I want to classify it, I have to make a categorical label and I have to say that if these are the parameters are matches, then you can predict what your output is. Example, logistic regression, support vector machine, decision tree, random forest, K means algorithm, K nearest neighbor, KNN. These comes under the supervised learning, what we call it as classification process. Next is going to be a regression. Regression is nothing but predicting the continuous numerical value. Here it is a discrete variables. Here it is continuous numerical. So this is the difference. So the classification goes with the prediction of discrete variables, whereas the regression goes with a continuous prediction, numerical values. So the output is nothing but a real numbers. Example, house prices, temperature, stock prices, age, like that we can go for it. So these are the how. So the house prices means, suppose if I need a 2-bedroom house in this location, then this the square feet I required means, depending on this area, depending upon the need, it selects what is the price. Right. So examples is linear regression, polynomial regression, ridge regression, and lasso regression are the different examples we can classify under the supervised regression model. Next is going to be your real-time application of supervised learning. So what are the real-time applications? We can study under supervised learning. I told that one is spam detection, image classification, fraud detection, medical diagnosis, weather forecasting, sentiment analysis. These are the different real-time applications we can move on to the supervised learning process. So spam detection means we can check whether the message is or the call is a spam message or not, or spam email or not, like that. Image classification is we can identify from the image. It is suppose if I'm going to see facial, recognition, if I'm going to do it, how the face has been. So what are the features I have to diagnose when I see it's a female face or a male face? If it is like this, what kind of classification you do? Like that we can go for. Fraud detection is nothing but, so suppose it mainly happens in the banking sector. So whether the transaction is in banking or e-commerce, by learning from a historical label the transactions, any fraudulent things that happen or not. Medical diagnosis, predicting the diseases. And sentiment analysis is depending upon the text or the customer review, social media. We can say that whether we can see how the person at presently is and what more, like that we can go for. Weather forecasting. These are some of the examples, real-time application we can see under supervised learning. Next, we are going to see that what is unsupervised learning. The name itself says that unsupervised. It does not require any supervision. It does not require any supervision. So then how? How will you define it? That's the next question. So they say that unsupervised learning, we are going to give only the input, but output we never give it. In the case of supervised learning, we give the output, but here we don't give the output. With the help of the input itself, the model trains it and it predicts the output. That is called unsupervised learning. Unsupervised learning is nothing but no supervision of your information is required. It automatically goes for predicting the output. So unsupervised learning is a machine learning approach where the model learns from the unlabeled data. So it itself, the machine itself takes the a decision and it provides the training data. Unlabeled data is the training data consists of only the input features with no corresponding output labels. I told you already, it does not have any output. Learning analogy is nothing but a teacher or a supervisor discovering the hidden patterns or the structure of its own. Right? So in the teacher, when we go for any process, so as a teacher, when she teaches the class or when he teaches the classes, she says she explains the concept. So after explaining the concept, the teacher may ask the question during examination, not exactly what she has given as an input in the class. Some twisted question she can. So your mission has to learn to understand what, because already it's an unlabeled data. So what? So already I have got the output, input. Based on the input, it starts relating that input with the question what it has asked and starts producing the output. So even the human being, we say that when I ask with a key value, with the key words, they try to say that, so this question is related to the things what they have done. So they start writing the answer for the particular question. Similarly, we are also making the machine to understand another different, right? So that is the analogy. The objective is to find the hidden patterns of the structures or relationship with the data. Here we are going to find out what is behind the screen, what is available. We have to dig the data. With the digging of the data only, we are going to create we are going to predict a new output. How does unsupervised learning works? Here also the same process. We go for data collection, we go for training, we go for pattern discovery. Here the patterns are discovered and interpretation out. So data collection, we know that we always collect the information, but the collected information does not have any labels. Training the data is the algorithm analyze the raw value, which is unlabeled form, to identify what similarity, what is the difference, what is the inherent structure. It tries to make the sense of the data by grouping them. So similarities means what's one group. Difference, what is the difference they find it out. They are in another group. What are the different structures it has. So we are going to take the unlabeled data and we are going to group it in a different form. So we are going to group it. So it's a suppose if there is a mass informations are available about. So for take a class, for example, class. So we are going to say that there are many students are available. It's a co-ed class. It's a co-ed classroom. So we have a girls, boys, everything. So we are going to segregate first girls and boys separately. After that, depending upon the age group, we are going to segregate them. And depending upon the marks they scored, we are going to categorize them. And depending upon, similarly, I can go for a different category so that I am making a grouping and I'm going to make that grouping. I'm going to put the label for the group what I have made. That is the thing your machine is going to do with it. So pattern discovery is the algorithm discovers the patterns, clusters, and relationship without explicit guidance. Here there is no guidance at all. Whereas in a supervised learning, somebody is going to guide it. So this is how you have to do it. This is how you have to. If you do it, you'll get this one. So something we are going to give a guidance. But here there is no guidance. It is self-growing processes happening in this case of unsupervised learning. So I'm getting the data. I am itself doing all the grouping. I am also making the machine to understand what I'm doing it. With that understanding level, what kind of output it is predicting, and whether the output what I'm getting is right or not. I have to check it again. So that if the difference is more, what is the process I'm going to do with what variations I have to make the machine to learn perfectly. Like that, without any supervision, without any guidance, with the help of the grouping data, we are going to label it. The machine itself is going to label it, and it is going to decide the pattern, and it is going to generate the output. So interpretation is nothing but human intervention is often needed to interpret the discovered patterns and determine their usefulness. So after discovering the pattern, some human intervention is definitely be needed, whether the pattern is right or not, whether the output is right or not. Somebody has to check it, whether we have to validate the output. That is called unsupervised learning. Next, what are the types of unsupervised learning we have? There are three classified into three categories. One is clustering, association, rule mining, dimensionality, reduction. So what is clustering? Clustering is grouping of similar data points based on their inherent characteristics. So after grouping the items with the similar characteristics, we are going to label that one. Examples, K-means, hierarchical clustering, DB-scan, Gaussian matrix model. So these are some of the algorithms we utilize in the case of clustering. Association rule mining is nothing but goal is discover the relationship or the association between the variables in large data sets. We are going to find out what is the proper relationship existing between the data what we get with it. How to this if then. The rules we have to create it. If this is a thing, we have to go for this. If this is not satisfied, we have to try for the other thing. So something we are going to set the rule. If then rules are applied frequently for co-occurring items. Examples: customers who buy a